It's very rare that I read an email that gives me one of those "wait, what?" moments. Rogers Corp have just announced a new 3D printing UV resin for SLA and DLP printers, which has a hugely improved performance as a dielectric for creating lenses and beamforming elements for microwave and mmWave antenna systems. The feature sizes that are possible means we'll be able to create 3D printed graded index or GRIN lenses for focusing and refracting microwave energy in the range from a few gigahertz up to at least 47 gigahertz. John Coonrod of Rogers Corp just dropped a short video introducing the material, and it looks mightily interesting. Graded index techniques allow a much tighter control of the quasi-optical properties of lenses for radio frequency energy by varying the refractive index of what's effectively a sort of metamaterial made from a 3D mesh like a sponge or a foam, with a continuously variable ratio of dielectric to air over the whole volume of the printed lens. The limitations, the resolution of the printer and resin, with feature sizes about a 20th of a wavelength probably being about the maximum to make the end result behave as a homogeneous dielectric rather than discrete structures. At 47 GHz, the wavelength is 6.4mm, so features need to be around 300 micrometers, which is pretty tough for home resin printers like the Anycubic and Elegoo models, with around 50 micrometers maximum resolution and layer thicknesses of the order of 150 microns. 24 GHz is much more achievable, and the lower ranges at 10, 5.7 and 3.4 GHz do start to hit limits of build volume. The build volume of an Anycubic Photon X is 192 by 120 by 245 millimeters, so 3.4 GHz starts to get pretty tough, but maybe sectional builds are possible. John claims in his presentation that this is the first high-performance 3D printable RF dielectric with loss tangents of less than a tenth of more common 3D printing UV resin materials. He does admit that the dielectric constant of this new material is still fairly modest at not much more than 2, but stresses that the 0.08% moisture absorbance is a really big deal. I think Preperm would probably dispute that claim to being the first, as their filaments has been available for some years now and with much higher relative permittivity and similar-ish loss tangents. But oh boy, check that water absorption. They're again limited by the minimum feature size of the printers that they're used in, but in general the filament printers have much larger build volumes, so I suspect that Preperm will continue to be the best for the 1 to 3 GHz range, and that the new resin will be the go-to material for 5.7 up to maybe 47 GHz. The microwave lens antennas I make use traditional machining with a special cross-linked polystyrene dielectric material called Rexolite 1422. It machines nicely and takes a good finish. Typically I use it for dial rod lenses which fit at the orifice of a round waveguide and refract the wavefronts to produce a more concentrated beam to illuminate an offset or prime focus dish, with a focal length to diameter ratio around 0.65, typical for broadcast satellite dishes for instance. Making graded index lenses from solid might be almost achievable at the lower gigahertz frequencies, but it would be rather like building a four-masted schooner from used matches, something to do when you're under house arrest perhaps, but otherwise somewhat of a time suck. Rogers Corp are normally very good about shipping samples of their products for experimentation and evaluation, but the EU sales office told me recently that they wouldn't have any samples of this stuff available. I've no idea of the likely pricing of the material, but once it hits the distribution channel I'm going to be desperate to get my hands on some of this gungy blue jollop so I can make some magic with it. It would be awfully nice if Rogers would make some samples of the stuff available so I don't have to go without food to afford it. Hint, hint. John also offered a teaser saying that the higher relative permittivity materials would be available in the future. The 3D print element of this work's been done by 3D Fortify. In a recent seminar they mentioned testing at 85 GHz and potentially getting into W band. Truly we live in interesting times, my friends.